with our answer.
Now let's do
And you can
question
follow
6.
this format because it will
Let's
really help
just
you in your
read
assessment.
out the
It will
question
save you a
once for
lot
our
of time.
reference.
You're not over explaining
The
stuff, you're
student did
staying
some more research
concise.
about
And
factors
then
affecting fish health in
the
aquariums.
examiner
They found some
whoever's
data
checking your
linking
paper,
breathing
they'll be
rate
able
to
to
water
understand what you're
temperature.
writing.
In
So
fish,
whatever
gills form the
paper you have,
oxygen
you can
uptake
follow this
system.
format.
The gills
And
open each time a
that
fish
is it
takes a
for this
breath.
question.
The researchers examined the gills to calculate the breathing rate of the fish at different temperatures. Now let's just look at the image over here. It just shows how the water flows into the mouth and out through the gills. And then they're asking us to calculate the breathing rate in breaths per minute at 20 degrees Celsius, but we don't actually have access to the video. So let's just do question 6b now. So 6b is going to be the data that the student found is shown below. So we see that the data he found, we see a graph. Just look at the graph for a second. Now let's just move on to the question. The question is asking us to find the outlier. So the outlier is just going to be this point right here, because you see all of these are like, this is an anomaly when you compare it to all of these values, because all of these are closely packed together and they show a trend, but over here when you look at this, it's like completely out. It's like not even a part of the value, so it's like an anomaly. So this is going to be our outlier, so we're just gonna write that down there. So we can just write the outlier. Let me just expand it for our understanding. The outlier is the data point at temperature. Let's just look at the temperature over there for our understanding. Like, we look at it closely and see that it's at 13 degrees Celsius, and it's at 13 degrees Celsius and it's at 40 breaths per minute. So let me just go back here. Temperature 13 degrees Celsius, where the breathing rate is 40 breaths per minute. So that's going to be our outlier. Now let's solve question 6c, which is asking us to outline the trend shown in the graph in part B. So if we just look at the graph over here, we'll see that the trend that it's showing is that the breathing rate, it increases until, let's say, like 60 or 59 to 62 breaths per minute. So around this area it's increasing. If you just look, if you zoom in and look closely, we'll see that. So right around here, like, we can take this as 62, I guess, because the point is not clear for us, so we can just take 60. It increases to a maximum of 60 breaths per minute, and then it begins to decrease. So the breathing rates per minute, it decreases after it crosses a certain temperature threshold. So it drops after it crosses 23 or 24 degrees Celsius temperature. After that it just drops. If after, like, as we get close to 30, the breathing rate drops. So that's a trend that we can observe. So as it is for 2 marks, you can just write, let's just keep it short and simple. Let's write 2 points. Let's write in context of the breathing, the breaths per minute, because let's just write 60. The breathing rate increases to a maximum of 60 breaths per minute. 60 breaths per minute. This is mentioned. It begins to decrease after it crosses the 60 breaths per minute. That's it. That's our trend that we can see in the graph in part B. That's it for question 6c. And one more thing I'd like to mention is that over here in second point, you can actually mention about the temperature as well. You can just write, after it crosses the temperature threshold of 23 degrees, where the breathing rate rapidly drops or rapidly decreases. And that's it. Now we're doing question 60. This is a common sense question, just asking us what might happen to the breathing rate at 0 degrees Celsius and the effect of this change on the fish. So it's a 2 marks, so we're gonna write it in 2 points. So first, if we just if you look at the graph, we see that in the beginning it rises, right? So if you decrease the value to 0 degree, obviously it's gonna drop. So the breathing rate will decrease when you move to 0 degrees Celsius. The breathing rate, let me just write this as a point. The breathing rate will decrease at 0 degrees Celsius. The second point, we can write that if the breathing rate decreases at 0 degrees Celsius, and then obviously the rate of respiration will also decrease, right? Which can eventually lead the fish to die. So we'll just write something that's less dramatic. Let's just go with the rate of respiration will decrease. That's the answer for question 6D. Alright, now let's do question 6C. The question is asking us to use the graph in part B and the table that is given over here, to estimate the dissolved oxygen content of water at the maximum breathing rate of the fish. So what we're supposed to do here is basically you have to let me just put a text box over here. You're just basically supposed to outline at which value do we have the maximum breathing rate of the fish. So if when we go back to the other questions, if we look at the graph, we can see that the maximum value is somewhere around 23 to it's between 25 and 20. So we can just take that as an example, and we can just take it as a starting point. If we just look at the values, we see this 20 and 25 over here. So we'll just take a value between 9.1 and 8.3 because we don't really know, right? The graph is not that clear, being honest. So we'll just go with 9.1. We'll take the value as 9.1 mgdm minus 3. Yeah, I can't put as a power. I just can't put as a power, so you can just take it like this. That's it for this answer. You can also go with 8.3 or any value that's in between this, because we can't really approximate it, right? We don't know how to calculate it as well, so we can just go with this answer. That's it for question 6C.